Hello and welcome to today's video. If you watched the previous installment of the 1995 Solectria E10 restoration, I was having a problem with one of the fuses. I popped the fuse for the battery charger while charging, and I thought that the fuse holder had opened up, but in reality I had popped this fuse. When I checked it was good, and that's the one that's marked 20 amp for the chargers. But in reality, I popped this one over here, which they fuse both the negative and positive side. So I popped this fuse. So after replacing it, I ran it for a little bit more, and you can see the fuse here is, well, trust me, it's popped. You can kind of see the black mark in it. So I went ahead and instead, I replaced the fuse and I plugged the charger back in, and it got really hot. So this fuse holder has just gone bad, and this fuse holder also gets really hot. So the two for the chargers were getting really warm. I picked up some replacement fuses, and I took because of the way these are designed, the spring is in the top. You can kind of see how it's springy, and that's what pushes pressure onto the base in here to make the connection. And I think what's happened is this spring is wore out, so I got some new ones, and I took the cap off of here, which have good springs, put them on there and ran it, and they still got really hot. So hot that you don't want to touch them, and that's what's melting the fuse inside. And these are 20 amp fuse holders and 20 amp fuses, and we're only pulling about 12-13 amps with the battery charger. It's 2 kilowatts at about 160-170 volts, depends on what the battery is, so you can do the math. It does a constant current charge, or constant power charge on it. So the interesting thing is I didn't want to go and pull the whole thing out to go replace these two fuse holders with these new ones, and we might end up with the same problem. So I went ahead and bypassed it. So you can see I've added this black wire here, which goes out. So I added another wire in here. This is the old chargers, or the old, it's still hooked up, so the positive still makes it there, and the negative positive accessory goes to the fuse back there and then back out to the main accessory, and the negative line goes in. You can see it goes into here and then goes over to that lug there on the other side of the current shunt. So this black line here is going from the other side of the current shunt. It comes out and goes to my new connector down here. So I added this, so that goes into here, and then the red wire goes, of course, to a 30 amp inline fuse holder. I have a 20 amp 600 volt fuse currently in there, and I changed the connector from the red, so that used to plug in there. I put a gray one on there so you can't accidentally plug that into the other one. But you could use this, I guess, for powering other 144 volt accessories that draw less than 12 amps. So anyways, I've got that hooked up, and it's now wired up, and got the current meter on there, and we'll go ahead and plug that in. So I've got the extension cord already plugged into the side of the truck, gas cap, charge port there, and I've got the extension cord comes over here to the wall, and now we're up and running. And so I'll pump 13 or so amps. Now the interesting thing is, in the previous video, I'd have to go back and watch it, I think we were doing about 12 amps. And I've made no changes to the charger or anything, so I think we were burning up 150 watts, because if it was, say it was supposed to be putting out 13 amps, right, and we were putting out 12.5 amps, then that was, you know, around 160, 150 volts at 1 amp, which would mean we lost about, the battery charger would think it's seeing the correct voltage, but would be losing that across the fuse, which means we might have been burning up 150 watts or so in the fuses themselves just in the bad connections, because the fuse holders that I replaced, those are the ones I replaced, and they came out of Solectria E10, and I think they were just internally corroded and rusted, and we're making a high resistance connection. This, like by now, if I touched the fuse, it would be so hot you couldn't touch it, but this is like cold. This is a 30 amp fuse holder, and we should be plenty good for only putting out 13 amps or so to charge the battery. But yeah, so that's all working. Oh, I also picked up for a double pull, double throw 12 volt automotive relay, 30 amp, and a socket for it. So I will wire that in to do the daytime running lights. Proposed plan is to tap into the parking brake signal that the parking brake is engaged, and then have the relay powered by the key switch, and then the parking brake signal will keep it normally closed, and then when you release the parking brake, it'll click open to normally open, and that will cause the headlights to turn on. At least that's the plan. We'll see what happens. Yeah, anyways, yeah, I don't know the polarity of the parking brake switch, but hopefully we can make that work. And that's why I got a normally open, normally closed. So I got both options there, and then of course I can hook up, I can either be high side controlled where I feed this to 12 volts, or I can be low side controlled where I feed this ground to make it flip on. So I think I've got all the bases covered. We'll get that working here. So that should be the next video, but yeah, we're definitely charging. Things aren't getting hot. It's nice and cold. Yeah, that's what I would expect. No heat at all. Yeah, before, like, by now it would have popped. These things would have been so hot you couldn't even touch them, but everybody should be cold because there's no current flowing through there now. It's been bypassed. So anyways, if you wanted to see how I did that, you have to go check out the pictures. Probably have them uploaded by the time this video's finished uploading. And yeah, anyways, thanks for watching.